Good morning, everybody. This is a live severe weather briefing, and we have a lot to talk about. An enhanced risk across portions of the mid-Atlantic, northern Virginia, central and eastern Maryland, portions of the Delmarva Peninsula, even far southeastern Pennsylvania into southern New Jersey has the potential of tornadoes, and that includes a 10% risk for tornadoes. We've also got Hurricane Nana to discuss that came in as a Category 1 hurricane in southern Belize last night. It's weakening into a tropical storm with a deadly mudslide threat, flash floods as well down there in Belize, portions of Honduras as well. And there's a couple more waves that just came off of West Africa that we're keeping a close eye on. The quick glance at the long-range model shows that those waves will likely mature into intense hurricanes, at least one of them, and they should recurve up toward the Bermuda area. There's a big trough coming into the central U.S., but I'm still going to keep a very close eye on it. I'm not sold on that recurvature, and I think that it could still head a little bit west and potentially threaten the east coast of the U.S. And also there's an early season snow event that we got to keep an eye on. That's going to happen early to middle next week over portions of Colorado and New Mexico, mainly in the mountains, but somewhat in the high plains and the foothills of those two states could get impacted, at least if you believe the Euro model. Some of the other models, like the updated GFS, are not showing that at all. And I am going to keep a very close eye on the severe weather threat across the mid-Atlantic. This circled region down here, that's where the enhanced risk is located. And you can see that the main wave, this is 500 millibars, the main wave is ejecting up into Quebec. So if there was heat, moisture, instability up there east of this wave, this is where the main low-level jet's going to be. This is where the best kinematics are up in Quebec, but the thermodynamics are just not going to be in place up there across Quebec to get a robust tornado threat. I do think there's a chance of some water spouts across northern Lake Huron with a lot of cold air aloft. Those relatively warm Great Lakes waters are definitely going to yield a water spout threat across the northern Great Lakes with all this cold air aloft, with this upper level system anchoring in over eastern Canada. But then down here where the enhanced risk is located, you can see it's just on the southern fringe of that stronger flow, and there is a little bit of a speed max down there as well, and that could excite a mesoscale low-level jet just to the east of the Appalachian Mountains. It happens a lot out there in the mid-Atlantic, where you get a little stronger than normal southerly or southwesterly low-level jet over the mountains there. But in general, the main wave is ejecting up into Quebec. That's bringing the best kinematics off to the north. And even though there are some deep dew points down here, the lapse rates are incredibly impressive. There's a relatively minimal elevated mix layer or dry air that's coming in at the mid-levels, and we're going to analyze that in the soundings as well. And the models are definitely picking up on those weaker than normal lapse rates. A little bit of a warm layer as well at 3 kilometers. So that's going to keep the storms relatively isolated, but at least according to the HRRR, there is some favorable soundings for an isolated tornado threat. Some of the other models like the NAM model, the RAP, aren't as favorable in terms of low-level wind shear as the HRRR, but I do believe that encouraged the issuance of enhanced risk, the HRRR down there, given the signal of supercell storms that should develop by late afternoon into evening. And that enhanced risk was for wind and also an isolated tornado threat down in the mid-Atlantic. It didn't materialize yesterday. There were no tornadoes, no tornado warnings out there, and just too much cloud cover, a lack of instability. And really what it has to do with is this main wave that's ejecting up into Quebec instead of punching down into the mid-Atlantic. I would reserve an enhanced or a moderate risk for those setups where there's a big-time wave ejecting in with the best kinematics over the mid-Atlantic. But that's just not the case for this setup. Still, though, there is a conditional threat for a tornado and isolated supercell storms here, central and eastern Maryland, northern Virginia, far southeastern Pennsylvania, the normal locations out there. But looking at the low-level jet, here is 850 millibars, and note how the strongest low-level jet is off to the north, not surprisingly, up into Quebec, up into this region. And that's where the most of the jet dynamics are located. The upper level system's punching up in there, a pretty strong 850 low located over James Bay. But down here on the southern fringe of that upper level flow, you can see just a little bit of some southwesterly flow at 1 kilometer. That's a low level jet that is a little bit stronger than you might expect, and it's to the east of the Appalachian Mountains there, even though the main wave is punching up into Quebec. A lot of times in the mid-Atlantic down here, you'll get this mesoscale enhancement of the low-level jet just to the east of the Appalachians. Moisture is usually not a problem in these setups this time of year, especially with those dew points in the mid-70s. But overall, this looks like a conditional setup to me, with the main wave coming up into Quebec, and just a subtle fringe wave down here, down into the mid-Atlantic, but still might be just enough to fire a supercell or two. It only takes one supercell storm producing a family of tornadoes to cause big problems, or even one tornado to cause big problems. And looking at the forecast soundings, at least according to the HRRR, even with the southern fringe of that upper level flow, and with marginal lapse rates and a little bit of a warm layer at 3 kilometers, the models still fire isolated supercell storms there, and the soundings do show a tornado potential that's conditional on those supercell storms really amping up. And not surprisingly, the main surface low is also up in Quebec. That's where the main kinematics are located. We've got a 982 surface low up there, vertically stacked from the surface up to 1 kilometer, and then even up at 500 millibars, a stout wave up there. But if you factor out thermodynamics and just go by pure kinematics, I would want to target up here just to the east of James Bay, out ahead of that surface low, out ahead of the 850 low where the core of that main low-level jet is located. But I just don't think the thermodynamics are going to be in place to get a big outbreak of tornadoes up there across Quebec. And then down here you can see just kind of a lack of a surface low, lack of surface pressure falls, and that's because it's really along the southern fringe of that upper level winds. There is just a bit of a subtle southwesterly low-level jet that develops just to the east of the Appalachians, to the east of that mountain barrier. But overall, it's a pretty conditional setup, but a lot of times those are the ones that end up happening down in the mid-Atlantic. I just think it is quite a little bit more conditional than the enhanced risk is showing there, but I'm entitled to my opinion out there, and I do think there's going to be a couple of supercell storms. And if any of those develop along that pseudo-warm front, especially here in Maryland, far northern Virginia, eastern Maryland, I do think there's a chance of a stout tornado threat that could develop with an individual storm, but it's more of a conditional threat on if those surface-based storms get going. And here you can see the NAM forecast, storm relative helicity in the lowest kilometer. It is just a little bit marginal down in this region, and a lot of the wind shear is actually over the mountains. You can see just to the east of the mountains, even with that southwesterly low-level jet at about 30 knots, pretty marginal 0 to 1 kilometer storm relative helicity. So unless there's some incredibly deviant motions, which there is a chance given how you're on the southern fringe of the mid and upper level flow, but the HRRR has a little bit stronger 0 to 1 kilometer shear, and I'm going to pull some soundings from that, show a couple of the differences between the models, and I think that the HRRR, that higher resolution model, is picking up on a little bit stronger of a low-level jet just to the east of the Appalachians, kind of enhanced by that mountain barrier to the west of it that is the Appalachians, and sometimes you can get a little bit stronger than normal low-level wind shear to the east of the mountains across the mid-Atlantic region, northern Virginia, central and eastern Maryland, southeastern Pennsylvania, and that could be the case here with the NAM. This is the regular NAM, so the coarse resolution of that model may not resolve just how much the low-level jet's going to increase just to the east of the Appalachians. But I wanted to say that all the models are not on board for a widespread outbreak today, that's for sure. It is quite a conditional severe weather event. And here's the surface map showing those dew points in the mid-70s. That's one thing that is definitely not going to be an issue, is the low-level moisture. And really the surface-based cape based on that moisture. But when you look at the full sounding, you can definitely see that the lapse rates aren't incredible out there. And there are definitely some holes in this setup. The lack of a robust elevated mix layer or dry slot that's coming in at 500 millibars. But still plenty of moisture out there. Eastern Pennsylvania, temperatures are in the low 70s, but temperatures are approaching 80 across central and eastern Maryland. And basically unimpeded heating that's happening there to the east of the Appalachians. Cloud cover, though, in the heart of the mountains and to the west of the Appalachians. And many of the models are also showing quite a bit of cloud cover across the target area. So that's one thing to keep in mind. But really, it looks like to the south of this line, you've got temperatures near and approaching 80 off to the south. Across eastern Pennsylvania, you've got temperatures in the low 70s. The slight risk, basically the enhanced risk, starts right at the Pennsylvania-Maryland border. And you don't have it's not like a traditional tornado setup. When you wake up in the plains and you look up in the morning and you see those low clouds ripping from south to north just above the head, just like you can touch them. That's that strong low-level jet that contributes to big low-level shear and ramps up in the middle of the night. And still exists in the morning hours before mixing and before heating of the day kicks in. You're not seeing that right now in the target area across the mid-Atlantic, and that's because of the lack of pressure falls to the west. Most of the energy is ejecting up into Quebec. You're really on the southern fringe of the stronger mid and upper level flow, and that low-level jet doesn't develop until about 0Z, so about 7, 8 o'clock Eastern time. That's when the southerly southwesterly winds really start to increase to the east of the Appalachians, and the tornado threat is definitely going to hinge on whether that low-level jet can develop a little bit earlier than those models are showing. But moisture is definitely not going to be an issue. And here's that enhanced risk issued by the Storm Prediction Center across the mid-Atlantic. I do think that this setup is going to be a little bit more conditional than is shown here, but these are a lot of populated areas. The I-95 corridor goes through here and includes the Delmarva Peninsula. So it's important to stay tuned to those watches and warnings here across the target area just because of the high ceiling of severe weather. So if there is an isolated supercell or two moving through this area and it's producing tornadoes, it's going to cause major problems. And the people out here just aren't used to tornadic storms. They're really staying tuned to those warnings all the time. And here's a marginal risk up in northern Michigan across portions of the northern Great Lakes. And with the very warm waters of northern Lake Huron, Georgian Bay, I could see some water spouts off of this with such cold air aloft with that vertically stacked upper level system that's ejecting into Quebec and also here across southern Ontario. Most of the pressure falls and cold pocket air is centered over James Bay. Probably going to be some big water spouts up over James Bay as well. But with that cold air extending south over the northern Great Lakes, I could definitely see some water spouts across northern Lake Huron. So let's look at the HRRR and see what all the fuss is about here. And a lot of times the HRRR is a driver of these outlooks that are issued. So when the HRRR is showing supercells in a favorable setup, it's all hands on deck. And the HRRR is showing more significant severe weather than some of the other models. It does show this southwesterly low-level jet that's developing here at around 0Z. This is actually about 7 p.m. Eastern time. And at this time, 6 or 7 p.m. is really when these southwesterly winds about a kilometer above the ground start to ramp up just to the east of the Appalachians. Here you can see higher elevations kind of depicting that flow closer to 850, getting squeezed over the top of those mountains. But really just to the east of the Appalachians, you've got a 30-knot southwesterly low-level jet and pulling some soundings from northern Virginia into eastern Maryland. They do look conducive for even a tornado threat. The Cape, however, this shows that how spotty those lapse rates are across the target area. The Cape here looks a little bit spotty, and this is about what you'd expect when the main wave is ejecting into Quebec, and you're just looking at the southern fringe of that stronger mid and upper level flow. You'd expect Cape to be just a little bit more spotty. If you had a big trough ejecting here with a stout elevated mix layer across this warm sector, then you'd see the surface-based Cape fields be a lot more robust. You wouldn't see them be as spotty as they are here across central Virginia, even with a surface map that shows mid-70s dew points. But it does look like there's some better instability here, banked up against the mountains across northern Virginia into eastern Maryland. Possibly the HRRR is hinting at a pseudo-warm front that develops too. And with that low-level jet not really becoming too robust until about 6 or 7 p.m., that warm front's probably just going to be anchored right about where we've analyzed it on the surface map. Central Maryland south, temperatures are near 80, even to the low 80s. Across eastern Pennsylvania, temperatures are in the low 70s. And the HRRR is really anticipating this warm front, or that differential heating boundary, to remain over the same location, draped across Maryland, with those supercells moving parallel to that boundary. There is a chance that along that pseudo-warm front, there could be a bit of an enhancement of the low-level shear, but I'm not seeing those easterly surface winds that you'll often see in front of these pseudo-warm fronts. I'm just kind of seeing a diffuse, weak southerly flow this morning to the east of the Appalachians. And then at about 6 or 7 p.m., that southwesterly wind at about 30 knots develops a kilometer above the ground, and that could act to enhance some of that low-level shear, especially near that differential heating boundary or that warm front. And here's the sounding, and this is the forecast photograph by the HRRR, and this was picked out right along that pseudo warm front that we were talking about. That's in eastern Maryland, central Maryland, and this is a pretty favorable photograph there for a tornado threat. The NAM model shows a weaker low-level jet, and it has more of a flat photograph, closer to a straight line photograph. But the HRRR that has the strongest low-level jet, about south-southwest or southwesterlies at about 30 knots, this has the most favorable photograph, and it's got these relatively diffuse, weaker surface winds, and that's allowing there to be about 20 knots of 0 to 1 kilometer shear in this layer. And there is quite a bit of helicity on this sounding too, at least along that pseudo warm front. This area between the storm motion vector and the photograph curve is proportional to the storm relative helicity within that layer. And this 1 kilometer wind of about 30 knots is really what caused that 10% tornado risk and the enhanced risk to be issued across the mid-Atlantic. The other models though, the RAP, the NAM model, show a little bit of a flatter photograph. Lapse rates are just a little bit weak as well. There's a warm layer at about 3 kilometers, and the HRRR is also picking up on the reduced storm coverage due to that as well. But this is a curved photograph, and even though it is on the southern fringe of that stronger mid and upper level flow, you still got 40 knots or so at the mid levels up there to evacuate the rain and the hail from the updraft effectively. Here's the storm motion due east at about 30 knots, which is parallel to that differential heating boundary that could tighten up a little bit closer to 6 or 7 p.m. So when you look at the HRRR, it definitely paints a picture more of a tornado threat could evolve. But then you look at the thermodynamics a little bit more closely and not just the raw Cape fields. And look at how saturated it is as well through the entire layer. So what happened yesterday to prevent supercells from developing is there was quite a bit of cloud cover. A little bit of a warm pocket as well, just above the ground. And it looks like that's also going to be the issue today. And a lot of that is due, in general, with that the main wave ejecting into Quebec, Ontario and Quebec. The main surface low, the main 850 low, is located over James Bay. And really are just in the very southern fringe of that stronger mid and upper level flow in the mid-Atlantic. And so that's why I don't think that this is going to be an incredible setup, but it is conditional. So if a surface-based supercell does get going in this environment, and we do realize some of that wind shear, then I do think that that we could realize that tornado potential. And I also wanted to go over the potential for early season snow coming up ahead. And this is the European model, 500 millibar map, and you may have seen on social media that some meteorologists were posting that snowfall map that showed Denver just getting annihilated by big time snow. That was just one run of the European and one model that showed that solution. Since that time, the European has moved that snow zone around a little bit, focusing it a little bit further south, Trinidad to Raton Pass and the adjacent mountains, but still the mountains of Colorado get hammered. But the GFS model and other models do not show this happening. The ensembles do show a snow event happening, but the actual operational GFS does not. And the reason that the European shows this is because of this very strong flow, very north-south across western Canada and the upper levels. This is a definitely backside loaded wave here, much more meridional and digging off to the south. But then you look at the GFS, and you can see how flat that flow is, more zonally oriented, not as much oriented to the north-south. And I think that the European is more accurate. I think that heavy, more dense, colder air has the potential of doing a lot of surging a lot further south and having a lot more buckling in the upper level flow. And with the jet having this big time speed max in the backside, it seems like the European is a more believable solution with more meridional, more north-south oriented flow from Canada down into the western U.S., causing that trough to dig and causing that cold air to bleed south just to the east of the Rockies. So moving forward on look at that wave that's created by the European. So with all that flow across western Canada, it causes this very stout vortex to develop on the European. It seems like that's a long way to go from just being a speed max in the backside of a relatively zonal flow pattern to really cause a very potent vortex like this to drop south across the Four Corners region. But by Tuesday morning, that vort is going to be centered over northern Utah. When we look at the GFS solution, has a much weaker, further east wave, and that's because it transitions from that relatively zonal flow at the speed max on the backside to a less potent wave that's digging off to the south. So there are dramatic differences between the two solutions. This GFS solution is going to result in very little snowfall, and then it's going to cut off across the southern plains by the middle of next week. Looking at the European model, look how they diverge. The European creates a cutoff system over the Four Corners. This is going to allow a front to surge to the south, just to the east of the Rockies, and continue to crank out upslope snow from northeastern New Mexico into southeastern Colorado. If this solution happens, then we're going to be talking about quite a bit of snowfall across the front range of Colorado, in excess of a foot, across the mountains there of southern Colorado into the mountains of northern New Mexico. San Cristo is out there, and some high plains insanity snowfall as well. Trinidad, off to the east of Trinidad, to the west of Lamar, near Raton Pass, to the east of Raton, Capulan Volcano out there. All those areas are going to get rocked with this solution, in addition to the Colorado Front Range. But this solution is definitely backed off a little bit on the snowfall across Denver, but still has several inches across the Castle Rock area. But that's assuming that system becomes cut off across the Four Corners, and realizing that the GFS model does not show that at all, and just shows a little bit of snow at the very higher peaks up in Wyoming. And that's because it just doesn't show the system digging south, becoming cut off, and then dominating across the Four Corners. And that shows you how the models will diverge, just based on a little subtle difference early on in the period. When you look at the 500 millibar map, the European has just a slightly more potent flow on its backside, a little bit more north-south, and that's just enough to peel off a cutoff vortex off of the western lobe of this relatively zonal flow, whereas the GFS has it much more zonal, less potent of a wave, more flat flow over this. I could see the European model happening. Of course, I'm excited. I kind of want it to happen so I can cover some of this early season snow. Also, if this European model happens and cuts off that system over the Four Corners, that's going to leave the southeastern U.S. a lot more vulnerable to hurricanes as well, whereas the GFS model, if that solution evolves, it's going to bring that trough into the central U.S., and then that's much less likely for a hurricane impact across the East Coast. And I was looking at the GFS model for those two waves that are coming off West Africa, and this solution right here from the middle of next week will cause an earlier recurvature. This Bermuda high is just a little bit further east, and that'll cause an earlier recurvature out near the island of Bermuda for those next systems in about 8 to 10 days when they start to arrive in the Atlantic. But if the European model is accurate, then we're likely going to see a potential impact of the southeastern U.S. So it's got a much further west location of that cutoff low. It does have a weaker, flatter trough across eastern Canada, but this would potentially allow a hurricane to come in over the southeastern U.S. So really it depends the future of these storms, the hurricanes off the coast of Africa, the snowstorm across eastern Colorado and northeastern New Mexico. All of it depends on whether you believe the GFS solution or this solution in the European cutting off that system over the Four Corners and then churning out days of snowfall through the entire week. But what a different evolution in the upper levels between the European and the GFS. This GFS solution, middle to late next week, would likely lead to a tornado threat and a fall season tornado threat here across the southern Great Lakes, portions of the Midwest, central Mississippi River Valley. This to me looks like a tornado setup in the GFS that could happen. So this just goes to show you how crazy inaccurate right now the long range models are, and we're just going to have to let it play out. I'm going to continue these briefings every single day that we do them. There it is. I was worried that this thing froze up a little bit, reading through the comments. Hello, guys. So that's what we're looking at severe weather-wise. I think that in the tropics, these are the two waves that we're monitoring out there. These are the two waves that just came off Africa. And I think if you believe the European solution, then these waves could have an impact across the southeastern U.S. I think, though, that with the GFS solution, with that trough anchoring over the central U.S., that will cause these to recurve and potentially impact Bermuda and then lift north across the northern Atlantic. If the European happens, though, and that upper level system cuts off over the four corners, then I think that these disturbances will be allowed to threaten the southeastern U.S. There'll be a further west extension of that Bermuda High, which will act to block that recurvature. Here you can see Nana spinning over interior Belize, Guatemala. They are probably causing major mudslides, major flooding. Max sustained winds are at about 60 miles an hour now as it continues to spin down over land. There is a chance that the remnants of Nana and some increased convection could migrate over the Bay of Campeche and then potentially become a tropical system in the Gulf as well. That'll have to be a scenario that we also monitor. And then here's Tropical Depression Omar, basically irrelevant of portions of the northern Atlantic, subtropical Atlantic up there. But these are the systems to watch just off the coast of West Africa. They've got a chance to develop, and many of the models are showing this one becoming a major hurricane, whether it recurves or comes a little bit closer to the coast in about 8 to 10 days. So quite a bit to watch with the snowstorm, the conditional tornado threat today across portions of the mid-Atlantic, even though the main wave ejects into Quebec. And then we've got these tropical systems there in the open Atlantic to watch. So that's my severe weather briefing today. I know it's not as exciting as some of the other briefings, but I'll be going live later on this evening if that severe weather threat does evolve across the mid-Atlantic. Again, here is that enhanced risk that is basically from the Delmarva Peninsula, far southern New Jersey, central and eastern Maryland, and northern Virginia. We'll definitely be tracking it on the Radar Omega app, tracking the high-resolution radar data as this unfolds. And I think there's also going to be that water spout threat across the northern Lake Huron. So I'm going to also try to see whether the GFS or the European model is correct, and I may go cover that early season snowfall near Raton Pass. I may also wait for those tropical systems off the coast of Africa, but if the GFS is accurate, then I may even end up chasing severe weather, fall season severe weather across portions of the central U.S. So it's that time of year when you can get any extreme weather hazard, and we're going to break it down here. I hope you guys enjoy my weather reports and have a great rest of your Thursday. And we'll keep slinging these lives, and I hope that you enjoy them and can even learn a little bit as well. Thank you, everybody, and have a great rest of your day.